What's up YouTube, this is Demkeys back again with another Unity tutorial, and this is going to be a video on how to zoom in and out with the camera using triggers. So recently one of my viewers contacted me saying that he was making a side-scroller game where he wanted the camera to zoom out in certain areas and smoothly zoom back in certain areas, and he wanted to do all this using triggers. So I decided to work on a game development technique for that, and that's what you'll be learning today. Alright, so what we have here is an empty scene. I'm going to create a quad and make 3 duplicates of it, so we have 4 quads in the scene. One of these is going to be the ground, so let's name it ground. The next one is going to be player, and the other two are going to be out trigger and in trigger. Alright, let's start with the ground. Bring the ground down and just flatten it and stretch it, so we have ground. Next is our player object. We're going to leave it as it is. Next, the out trigger. Make it long and just a little thin. And okay, delete in trigger and just make a duplicate of out trigger and then rename it to in trigger. Alright, now select all 4 objects in the hierarchy and see where it says mesh collider. Remove that. Make sure all 4 are selected, so the mesh collider gets removed from all 4 of them. Then hit add component, making sure all 4 are still selected, and add a box collider 2D, not a box collider, just be careful of that. Alright, next click edit, project settings, tags and layers, and we're going to add 2 new tags. One is zoom out trigger and the other is zoom in trigger. Assign the zoom out trigger to our out trigger object and the zoom in trigger to our in trigger object. Also select out trigger and in trigger, and under box collider 2D where it says is trigger, check that, because these two are now triggers. We don't want our player to collide with this object. We want something to be triggered when the player passes through this collider. Alright, next click player and add a rigid body 2D component to the player. Next, create a new script. You can call it whatever you want. I'm going to call it player move script 03 and attach this script to the player. Now open up the script in MonoDevelop. Now we are first going to create all the variables that we are going to need. So first is public float move force. It's a public float so that we can view the value from the inspector panel. So move force is going to be used to control the movement force of our player. Next, public float cam size. This is going to show us the current size of our camera. Next, cam size limit. This is what we'll use to stop the camera zooming out at a certain point, because it shouldn't be an infinite zoom. It should actually stop at a certain point. Next, public float increment. I'll explain this later. Next, public float time lerp. This also I'll explain it later. You'll see what it does. And finally, we need to create 2 public bool variables. One is should zoom in, which is false, and should zoom out, which is also false. Next, under the update function, create a new function called zoom in and copy that, and under zoom in create another function called zoom out. Alright, next float h equals input.getAxis horizontal multiplied by move force. Okay, input.getAxis horizontal is going to return either -1, 0 or +1 depending upon which key is being pressed, and that value is then going to be multiplied by move force. So if move force is, for example, 20, then the value of h is either going to be -20 or 0 or +20. Next, rigid body 2D, be careful of that, dot add force vector2 dot right multiplied by h. Let's go back to Unity and just make sure this is working. I forgot to assign the move force 20. Alright, so this works. Next, under update, create another function, void on trigger enter 2D, which takes in a parameter of collider 2D, call it call. I've explained how triggers work in one of my previous videos. The link is up on the screen right now and in the description down below. Check it out if you don't know how triggers work. And I'm also mentioning a link to my video on collision detection. Check that out as well if you don't understand how collision works. So if call.gameObject.tag is equal to, what is the tag's name? Zoom in trigger. Then else if call.gameObject. Just copy this and then change this to zoom out. This line over here is going to check whether the object that contains the trigger has the zoom in trigger tag or not, and if it does, then should zoom in should be equal to true, but if the object has a zoom out trigger tag, then should zoom out should be equal to true. Next, go back to the update function. If this seems confusing right now, just keep going with me. Eventually it might make sense. If should zoom in, this is the same as writing if should zoom in is equals to true. So basically we are saying if should zoom in is equal to true, then call the zoom in function. Else if should zoom out is equal to true, then call the zoom out function. Now let's add some lines of code to the zoom in and zoom out functions. Okay, first let's check and see if these few lines of code over here actually work or not. Save the game, go back to Unity, let's play the game, and as you're going towards these two, pay attention to these variables over here. When you cross this one, should zoom out gets checked. When you pass this one, should zoom in gets checked. Now let's go back to the code and add some lines of code to our zoom in and zoom out functions. Okay, before that, let me just add a value, public float time lerp value. You'll see why I'm adding this shortly. And also, over here, let's add two lines of code. Cam size equals camera dot. Be careful over here. It's camera with a capital C, not lowercase c. Camera dot main dot orthographic size. Yeah. Um, camera dot main basically is the main camera, the first enabled camera, which has the tag of main camera. So that is this camera over here. It has the main camera tag and it's the first enabled camera as well. Alright, so cam size is going to show us our camera's orthographic size, which is basically just this size. Okay, I forgot to mention these things before. So what we are trying to do here is just change the size. This is going to cause the whole zooming effect, zooming in and out. And we have to change the size because this is an orthographic camera. If this was a perspective camera, then we could have just changed the Z value. Pay attention to this small preview over here. As I pull the camera back, it's zooming out, and as I take it forward, it's zooming in. But this is not a 3D camera, and when you create a 2D project, then you get an orthographic camera. So I don't want to put the users in a situation where they have to change their camera projection just to achieve this effect. That's why we are working with this camera, and that's why we are changing the size. Alright, so yeah, orthographic size is basically the size that you just saw. Next, time lerp value is equal to time lerp multiplied by time dot delta time. Next, in the zoom in function, if camera dot main dot orthographic size is less than cam size limit, then camera dot main dot orthographic size is equal to mathf dot lerp. I'm not going to explain lerp because I have done a video on this as well. The link is mentioned on the screen and in the description down below. So if you don't know how mathf.lerp works, then go check it out. Camera.main.orthographic size 2. That was the from variable. This is now 2. Camera.main.orthographic size plus increment. Let me just confirm. Okay. And then the time variable. So that would be time lerp into time dot delta time. So these lines of code are going to execute only if the size value is less than the cam size limit, meaning it's going to continue zooming. Wait, I seem to have mixed up the names. Sorry about that. Change this to zoom out and this to zoom in, because this logic that we are making over here, this is for zoom out. Sorry about that. Alright, so yeah, as the camera is zooming out, it's going to keep checking if the cam size has reached to whatever the limit is, and if once it reaches, it's going to stop zooming out. Else if camera.main.orthographic size is greater than cam size limit, then should zoom out is equal to false. Now just copy these lines over here and paste them in should zoom in, and let's just change a few minor details over here. If camera.main.orthographic size is greater than 5f, because currently the size of the camera is 5, so we want to return it back to that size. If it is greater than 5f, then continue zooming in, which means in this case we'll have to change increment to a negative value, because if you notice over here, as you increase the value it zooms out, and as you decrease the value it zooms in. And also change this to if camera.main.orthographic size is less than 5f, then should zoom in should be equal to false. Now let me explain how this is going to work. So you start your game, and then at some point update is called, at which point it's going to check for input, and it's also going to check if should zoom in is true or not, and also if should zoom out is true or not. How are they going to become true or false? If the player triggers that trigger, then this code block over here is going to check if the object that contains the trigger has this tag or not, and if it has this tag, then should zoom in will be equal to true, but if the object has this tag, then should zoom out will be equal to true. Now keeping that in mind, update is called many times, so at some point when this block over here executes, should zoom in will be called, because at some point should zoom in will be true. If it's true, zoom in will be called. If it's not, in which case should zoom out would be true, then zoom out function will be called. And this is our code for zoom out and zoom in. Let's look at zoom out. If camera.main.orthographic size is less than cam size limit, I've already explained this, then camera.main.orthographic size is equal to mathf.loop. I'm not going to explain this in a whole lot of detail. It's basically going to take the value from here to here. This line of code is basically the size plus whatever this value is going to be, and it's going to take it towards this value within this amount of time. That may not be the best explanation. Like I said, if you don't know how mathf.loop works, then go check it out. Now if this is not true, but if this is true, basically meaning that camera.main.orthographic size is greater than the cam size limit, that means we should stop zooming out, at which point should zoom out will be false. And so when the update function executes again, this is not going to be true, and so zoom out will not be called. Now the same logic works with the zoom in, only in this case if camera.main.orthographic size is greater than 5, then we want to continue zooming in. That means we want to continue reducing the camera's size. The same mathf.loop, only in this case we change increment to a negative value, so it's going to start decreasing the size, hence zooming in by whatever amount of time it is. and if this condition is not true, but if this is, meaning if camera.main.orthographic size is less than 5f, we have reached our limit and we don't want to zoom in anymore. So should zoom in will be false, and so this is not going to execute. I hope you understand how this is working. Save the script, go back to Unity and click on the player. We need to assign the values now. Let's move this up a few steps. Yeah. So move force is already set to 20. Cam size is going to be set for us. Cam size limit, this should be 20. It doesn't have to be 20, it depends upon how much you want to zoom, so it's up to you. Figure it out. Increment, let's set it to 3. Time lerp, let's set it to 1. I'll explain why shortly. Time lerp value is going to be set for us, and these two will also be set depending upon where we are. Alright, so I think we are ready to test it out. Run the game. First, cross the out trigger. The camera zooms out. Then cross the in trigger. The camera zooms in. Now you see this value over here, time lerp value. This is the value that is being used in our mathf.lerp function. We are not using the value of time lerp value variable, but it's the same value because it's time lerp multiplied by time.delta time. And you'll understand why this value is so small once you understand how mathf.lerp works. Now keep in mind, this is not I'm not saying that this is the best method of accomplishing this task. I'm also not saying it's the most efficient method, but it is a method. It's something that you can use to understand how things work. Hopefully you can use this logic to make something of your own. You could build off of this. But yeah, that's it. I hope this tutorial was helpful. Do check out these other videos as well. The video on the top left teaches you how to create a 2D Mario style enemy patrol. The video on the top right teaches you how to create a parallax scrolling background. And in the bottom left is the Make a 2D Platformer Game Series playlist. I'm also accepting donations, so if you would like to help me out, you can send your donations to my PayPal email address, which is mentioned on the screen and in the description down below. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.
This is what they saying. What? How you feel, huh? This is what they saying. What? Yo, started out with nothing, then I turned myself to something. Everybody wanna claim a nigga when they hear you buzzing. Don't nobody wanna claim you when they hear you bugging. Not known to tell stories, not known for fronting.